Assalamualaikum warahmatullahi wabarakatuh. Today I will be explaining about risk analysis for constructing a low-cost housing settlement at the rural area in Malaysia. So this is my group member and my name is Muhammad Irfan bin Ismail. Okay, for introduction, low-cost housing development is vital for improving the quality life of low-income communities in rural Malaysia, such as government provide Rumah Mesra Rakyat, program perumahan rakyat aim to provide safe, affordable and sustainable housing while enhancing social well-being, reducing poverty and supporting balanced national development by limiting excessive rural-urban migration. The background, despite its importance, rural low-cost housing construction face many challenges, including limited infrastructure, financial constraint, lack of skilled labor, material supply issue, regulatory delays, and this uncertainty make risk analysis essential to identify potential problem early so we can manage this and completely successfully within budget and schedule while delivering quality housing to rural communities. So for SWOT analysis, there are 4 elements for SWOT analysis, which is strengths, weakness, opportunities, and threats. Okay, for strengths is the project receives strong government support and funding, which help reduce overall cost. And for opportunities, the housing project can improve rural living standard and create job opportunities for local communities. It also encourages development of facilities like school and clinics. And weakness, the project face limited infrastructure such as poor roads, not enough water supply, and lack of electricity. And also lack of skilled workers might cause a weakness for the project. And next is threats. The project may be affected by heavy rainfall, flooding, and fluctuating material price, approval delay, and resistance from local communities can also slow down project progress. So this risk identification. Risk identification is the process of recognizing and documenting potential risks that may affect the successful completion of a project. There are 10 risk identification, which is budget overrun. Project cost may exceed the planned budget. Construction delay, the project takes longer than the planned schedule. For infrastructure, basic facility like road, water and electricity are insufficient. Labor shortage, quality issues, safety hazard, which are the workers are exposed to danger. Environmental impact, construction may cause soil erosion and cause the flooding to happen, and because of improper land clearing. Community resistance, local residents may oppose to the housing projects, may cause protests, and regulatory delay, which is slow procedure. Or project approval take times to approve from the authorities. And lastly, maintenance issue. Housing unit may not be properly maintained after completion, reasoning because limited funding and lack of technical knowledge affect maintenance.
Risk Register Table. The Risk Register is an important tool in project risk management. It is used to identify potential risks that may arise during the planning, design, and construction of rural low-cost housing project in Malaysia. The Risk Register contains detailed information about each identified risk, including the type of risk and the corresponding response strategy, such as mitigation, avoidance, or acceptance. Regular review of the risk register ensure that all risks are monitored and managed effectively, enabling the project team to minimize negative impacts, optimize resource, and increase the likelihood of completing the housing project successfully. For example, budget overrun. Budget overrun is project cost exceed the allocated budget due to rising construction material prices, unexpected site condition, and additional work requirement that were not initially planned during the early stages of the project. Construction delay. Construction activity may be delayed due to poor weather conditions such as heavy rainfall, limited accessibility to rural sites, and delay in material delivery. Poor infrastructure. The lack of proper access roads, water supply, electricity, and drainage system in rural areas can slow down the construction activities and increase project costs and duration. Labor shortage. There is difficulty in obtaining skilled and experienced construction workers in a rural area, which may lead to low productivity for workmanship and extend construction schedule. Quality issue. Contractor may use low quality material or improper construction method to reduce costs, affecting durability, safety, and lifespan of the housing units. Safety hazard. Construction site in a rural area may lack adequate safety equipment, supervision, and training, increasing the risk of accident, injury, and unsafe working conditions for workers. Environmental impact. Land clearing and earthwork activity may cause soil erosion, flooding, and environmental degradation if proper environmental management and drainage systems are not implemented. Community resistance. The local resident may oppose to the project due to the land ownership issues, disruption to daily activities, cultural concern, or lack of proper communication and engagement with the community. Regulatory delay. Delay may occur due to slow approval processes from local authorities, changes in regulation, or incomplete documentation submitted during the planning and construction phase. Last but not least, maintenance issues. After project completion, for long-term maintenance may occur due to limited funding, lack of proper management, and insufficient technical knowledge among local housing management bodies.
So this is the risk matrix table. For this line is for probability value and this line is for impact value, and the other value is sum of multiplied by probability and impact value. We can see for high risk is above of 0.4, for medium risk between 0.2 until 0.4. So for the low risk is under 0.2. After that, this is the risk ranking. In the risk ranking, we can determine each event whether it is low, medium, or high risk by determine the risk score. For the budget overrun, the risk score is 0.64, which is high risk. Number 2 is construction delay. The risk score is 0.48, which is high risk. For number 3 is poor infrastructure. The risk score is 0.48, which is high risk too. For number 4 is labor shortage. The risk score is 0.36, which is medium risk. Number 5 is quality issues. The risk score is 0.48, high risk. Number 6 is safety hazard. Risk score is 0.24, high risk. Number 7 is environmental impact. The risk score is 0.32, medium risk. Number 8 is community resistant. Risk score is 0.36, which is medium risk too. Number 9, regulatory delay. The risk score is 0.48, high risk. And lastly, maintenance issues 0.24, which is medium risk. Next, I will explain about quantitative risk analysis and their purpose. So the first one is evaluates project risk using numerical values, cost and time. Second, shows how much money may be lost if a risk occurs. Number 3, helps project team plan contingency budget. And lastly, focus only on high and significant medium risk to keep analysis practical. And the purpose of quantitative analysis: first, estimate financial impact of major risk. Second, support better decision making. And lastly, identify risks that can seriously affect project cost and schedule.
Next, expected monetary value EMV method. EMV is used to calculate the expected cost of a risk. It considers probability of the risk happening and cost impact if the risk occurs. EMV formula is probability times cost impact. Why EMV is used? First, it's simple and widely used method. Second, helps estimate contingency budget. And third, allows comparison between risks. Next is EMV calculation for identifying risk. It is applied to selected high and medium risk only. Its cost impacts are based on realistic construction assumption. Higher EMV equal to higher risk priority, and it helps decide which risk need stronger control measure. So this is an example for calculation for identifying risk. Next is interpretation of quantitative analysis result. Financial and schedule risks have the highest impact on the project. Budget overrun, construction delay and quality issues show the highest EMV values. This risk requires strong cost control, good scheduling and strict quality management, and total EMV represents the contingency budget needed for project uncertainties. So for the key findings is high EMV equal to high risk priority. We need to focus should be on cost, time and quality control, and last one helps improve financial planning. Next, summary of quantitative risk analysis. The first one is quantitative analysis shows how the risk affect project cost in numbers. Second, EMV method estimates possible financial losses. And third, helps prioritize risk mitigation actions. Next is support better decision making and resource allocation. And the last one, increases chance of completing the project within budget.
Conclusion and suggestion. First, rural low-cost housing project improve living standard but face risks related to cost, time, labor, quality, safety, environment, community and regulation. Second, SWOT and qualitative analysis identify budget overrun, construction delay, poor infrastructure, quality issues and regulatory delay as key risks. Third, quantitative analysis using EMV show that financial and schedule risks have the highest impact, requiring strong control measures. Number 4, to reduce risk, project teams should improve cost monitoring, include schedule buffers, coordinate early with authorities, engage local communities, provide labor training, enforce quality control, allocate EMV-based contingency budget, and apply environmental management practice. Lastly, integrating qualitative and quantitative risk analysis help manage uncertainties and increase the likelihood of completing the project on time, within budget and sustainably.